Before you watch this video, make sure you have seen this video made by Veritasium. Riddle 1. When a cylinder was put on a slope, it alternated between rolling and not rolling several times. How is this possible? It is physically impossible for a solid cylinder to behave like this. Therefore, the cylinder must not be solid. The inner part must be filled with some sort of viscous fluid or sand-like material. When the cylinder is rolling, the material on the inside, which we will call material X, will get slightly behind and will get slanted. At a certain point, material X is at such an angle that it wants to return to its original, lowest energy state. Material X will now move forward. But since conservation of momentum requires the total amount of momentum to be constant, the cylinder will slow down. This process will now be repeated, hence the alternating velocity. Riddle 2. If you tie a string on the lower part of a bicycle and you pull on it, in what direction will the bike move? If we look at the bike as one rigid block, the answer might be obvious. The bike will come towards you. But if you take a closer look at the pedals, it appears that the applied force will result in forwards pedaling. So which one is true? To simulate in which way the pedals are moving, we need some data. Let's say that the wheel has a diameter of 1 meter, that the pedals make a circle with a diameter of 50 centimeters, and that the front gear is twice the size of the gear on the back. Assume that the wheel is rolling counterclockwise with a velocity of 1 meter per second. Both the wheel and its gear will have an angular velocity of 2 radians per second. Since the gear in front was twice the size, its angular velocity will be half of 2 radians per second. Now, this value can be translated into the speed of the pedal with respect to the bike, 0.25 meters per second. Or, in other words, the pedal will move towards you with a speed of 0.75 meters per second. Concluding, pulling on the string will result in both the pedal and the whole bike going towards you. One final thought though, if you pull on the bike sideways, it will fall over. Riddle 3 is about running 2 laps on a track. The first lap will be completed with an average velocity called V1. The second lap with V2. The average velocity of the 2 laps combined equals 2 times V1. What was the velocity at which you ran your second lap? The definition of average speed is defined as distance traveled divided by time elapsed. For lap 1, this equation will look like this: the length of the track divided by the time in which you ran it. The average speed of the 2 laps combined will be 2 times the distance divided by an unknown amount of time. But as we can see, this amount of time will also be t1. So in order to get an average speed which is equal to twice v1, you must run the 2 laps in a time which is equal to the time elapsed in your first lap. Therefore, the second lap was run in an instant, meaning infinite velocity. The last riddle is as following. What part of the train is always moving backwards with respect to the ground? To find this answer, we must look at the wheels of the train. It is given that the axis of a wheel has exactly the velocity of the train, and that the bottom part of the wheel has the same velocity as the ground. A straight line can be drawn between the 2 data points, resulting in a linear function for the velocity of every part of the wheel. It is fun to note that the upper part of the wheel is always going twice the velocity of the train. But what part is moving backwards? If we look at a side view of a wheel, we can see that the wheel is not resting on its lowest part. The so-called flanges are actually lower. These flanges are there to keep the train on its track, but are also the reason why there is always a part of the train moving backwards.